Hello everybody, in this video we're going to continue along our path to understanding how the planets are orbiting the sun. What makes the planets move according to Kepler's 3 laws of planetary motion? We really want to understand the physics of that, which means that we're going to have to take some time and review some basic physics terminology. I know this is going to be more physics terms than you're probably used to in a video, but it is absolutely quintessential to understanding the orbits of planets, which is kind of fundamental to astronomy in of itself. So in this video, I want to talk to you about what is motion. When we talk about motion, the movement of objects, what do we mean by motion? And how do we actually make things move? What induces and causes motion? And how can we actually measure that? So I'm going to talk about motion and force. All right, so let's start with just motion itself. Whenever we're going to describe the motion of something, say the travel of this ball as it goes back and forth here, if we want to describe the motion, then what we need to know are a couple of things. We need to know how fast it's moving and what direction. Now, speed is probably a term that most of you are already familiar with. And clearly, speed is related to motion. It's just how fast, how fast and what amount of time will it travel, will an object travel a certain amount of distance. So it's going to be distance per time. So just how fast something is going. So how fast is this ball moving along this area? You can measure it in things like miles per hour. You can measure it in, if we're going to use scientific notation, or not scientific notation, but the metric system and our SI metric system at that. We want to use the distance unit meters. We want to use the time unit seconds. So we want to know how many meters do you travel every second. So speed would be measured in meters per second. Other speeds, miles per hour, of course, kilometers per hour, light years per year, any distance divided by time. But if we really want to describe what motion is, speed is just telling us how fast. We want to know how fast in what direction. Is the ball moving at 5 miles an hour that way, or is it moving at 5 miles an hour that way? Those are two different ways to describe the motion. 5 miles an hour, it could be any direction. And if we really want to understand the motion, we need to know the speed and the direction. And whenever you combine those two ideas, speed plus direction, you have what we call velocity, a much more formal term, and it contains a lot more information. So speed is just what direction. Velocity is speed and in what direction. So we would now say it's traveling along this line right here. And let's just say that it's measured, say, 30 degrees away from this. So it gives us a speed and a direction. We could break that down if you're into physics and things like that and vectors, then you would have its x direction plus its y direction. And the combination of those directions would give you the overall velocity. Now, I know that is a little bit more than I expect you to really master for this class, but I just really want to hammer in that velocity is what we're going to be talking about in this class. So velocity is going to combine the speed, how fast, measured in meters per second, and in what direction. So am I going to go, if I go outside, am I going to run, if I'm going to run at, say, 5 meters per second, or move at 5 meters per second? I also, if I wanted to talk about my velocity, I'd say I'm moving 5 meters per second due north, an azimuth of 0. Or I could say that I'm moving 5 meters per second due east, an azimuth of 90. I could say that I'm moving at 5 meters per second, an azimuth of 45 degrees. So it's a speed plus a direction. And that is what velocity is. All right. So now that we know about velocity, we can talk about acceleration. Acceleration, and before I actually go through all the words on this slide right here and talk about them, I want you to just go ahead and think about, whenever I say the word acceleration, what comes into your mind? And a lot of you probably pictured acceleration of a car, something like that. You're sitting in a car, you stomp on the gas pedal as hard as you can. If you have a really high horsepower car, you probably get thrown into the back of your seat as the car accelerates. So it's measuring how many miles per hour you're changing in a set amount of time. Something that a lot of car people are interested in is the 0 to 60 time for a car. What is that? It's the time it takes for a car to accelerate from 0 miles per hour to 60 miles per hour. So acceleration is telling you how velocity is changing with time. how fast can you go from not moving to motion of 60 miles per hour? And that would be a measurement of acceleration, how velocity is changing with time. Formally, it is defined as the rate of change of velocity. So how many miles per hour are you changing your motion every second? But let's do this with the SI system, the metric system. So we want to say how many meters per second are you changing your speed or your velocity every second. So it is a change in your velocity. So we are measuring how many meters per second you are changing, which means that our SI unit for acceleration is meters per second squared. You can always call it meters per second, which we could use any other speed unit or velocity unit. We could say miles per hour per second if we want to talk about the 0 to 60-ish time. I also just want to note, just so you're in the world of physics, speeding up and slowing down are both acceleration. Speeding up is a positive acceleration while slowing down is a negative acceleration, but both are an acceleration. It is just a change in your velocity with time, a change in your motion with time. Now, if we want to bring this back to Galileo, because Galileo, what did he say? That objects, as they fall, they accelerate. So a free-falling body will accelerate as it falls. And we now know that that acceleration, and sorry, that should not say acceleration rate. I should be a little bit more careful with the language I use here. That acceleration, there we go. Make my physics colleagues happy, make myself happy. So the acceleration for free-falling objects is 9.8 meters per second squared. This is going to be a number that you're going to become very familiar with by the time we finish Unit 1, Part 3. So what is the acceleration rate? 9.8 meters per second squared. This is equal to 32 feet per second squared. And people are more familiar with feet than with meters, so I'll use this example. What that means is after 1 second of falling, this ball would have a speed of 32 feet per second. That would be its speed. After 2 seconds of falling, 32 times 2 is 64. It'd be traveling with a speed of 64 feet per second. After 3 seconds, 96 feet per second is the speed. So as it falls, it's getting faster and faster and faster. And the acceleration gives you a way of saying, oh, it's been accelerating for, at this rate, it's been accelerating with a acceleration of 9.8 meters per second for 10 seconds. That thing will be traveling at 98 meters per second after 10 seconds. Again, you'll never have to do calculations like that. I'm just saying all of this to help hopefully add a little bit of context of what's going on. Because now that we have gotten to acceleration, we can finally talk about motion, really, because what does it mean to change your motion? And that's where we want to get into this idea of a force. So I can have this ball just sitting here. It's not doing anything, has a 0 velocity. It's moving with a speed of 0 miles per hour. But if I want to make it move, I would have to do something to it. There would have to be something that would change its motion. Perhaps I should get something that rolls a little bit better. So I have a ball that's just sitting, well, it's supposed to just sit here. There we go. And then if I apply a force, it will begin to move. So in physics, we use the term force just for any influence that changes the motion of an object. So now that we know what a motion is, and we can describe it in terms of, with terms like velocity and acceleration, all a force is something that changes motion. So any influence that changes the motion of an object, whether it's me batting a ball around, pushing on a ball, or throwing a ball up in the air, or if it's gravity, the force of gravity causing it to fall. So a force is anything that changes the motion of an object. Whenever we use units of force, whenever we're talking about how we measure force, the measurement of force is the standard unit is called the Newton, named after Isaac Newton. And no, he did not name that unit himself. It was an honorary thing where we named the unit after the person that did all the work to describe the laws of motion, which is going to be our next video. So we have our SI unit for force as the Newton. If you want to know what 1 Newton is equal to, 1 Newton is 1 kilogram times meters per second squared. It's a kilogram meter per second squared. So that's just a whole combination of different units. Notice that's in red. I don't expect you to memorize what a Newton is, but some of you out there might be interested in physics. So it's always good to give that extra little bit of detail. And finally, we can talk about what we mean by a change in motion. We know now that a force changes motion, but what do we mean by a change in motion? By a change in motion, we're talking about moving from one speed to a different speed, having one velocity to a different velocity. So this could be not moving to moving. So if I'm going to bat my ball around, so it's just sitting here, and then I can induce motion by applying a force. Or it could be moving at one speed, and then I can hit it again, apply another force, and change its speed. So it could be from not moving to moving, or from one speed to another speed. It could, if we're talking about velocity, it could be moving in one direction to moving in a different direction. That's a change in motion, right? To be moving in one direction and then move into a different direction. So that would be a change in motion. And it could be either a change in speed, a change in direction, or it could be both at the same time. So really, you could summarize all that as it's a change in velocity. To change your motion is a change in velocity. But what was a change in velocity? A change in velocity is just acceleration. So you can see that all these things are related. So if you apply a force, something that will change something's motion, really what you're doing is you're inducing an acceleration on an object, which is a quantifiable number. And now we can start seeing how force is somehow going to be related to acceleration. Force changes motion, and any change in motion is an acceleration. So we got to just figure out how those things are related. That's going to be a topic for Newton's 3 laws of motion and an introduction to gravity, this universal force that everything that has mass has, that wants to make things, move, like fall. Okay, that's your brief introduction to the terms force, speed, and velocity. These are going to be quintessential. Watch this video over and over. If you have to, go look up some additional stuff online. I won't have you crunching through any equations with these ones. I really want you to just have a better sense of what these terms are, because I'm going to be using them regularly for the remainder of our discussion about how planets move, and it comes up very often in this class. Thanks for tuning in, and I'll see you in the next video.